atomic mass, mole, molar mass. Let's start off with the atomic mass. What is atomic mass? Atomic mass is the weight of an atom, the mass of the atom. What is the mass of an atom? That means in case if there is one single atom, what is the weight of that atom? And we know atoms are exceedingly small. They're too small to measure. For example, if we take a fluorine atom, and the weight will be 0.16 times 10 to the power of minus 23, or you can represent in the bottom figure. And these figures are too small to be able to measure. So we don't have the weight to measure that many decimal places. So scientists find there's another way of measurement. That is called the compare method. By a compare. So what's meant by compare? So they're using one atom to compare with another atom. And I'm going to give example what's that mean of compare. Initially, the mass of an atom they select is hydrogen. Why they select hydrogen? Because hydrogen are the smallest unit, the smallest atom. So they're going to select hydrogen to compare. Now let's give an example. If we want to work out the weight of a carbon, they will say, oh, it will worth around 12 pieces of hydrogen atom. So if you put 12 pieces of hydrogen atom, it will be equivalent to a carbon. So you can see the number 12. So that means it takes roughly about one carbon is equivalent to 12 pieces of hydrogen. And now let's take another example. Fluorine. What is the weight of a single fluorine atom? And it will equivalent to about 19 pieces of hydrogen. So it will be close to the 19 of the number. And of this method, it worked out very well. And this is a comparing method. So this giving the periodic table of the ratio relationship, all atoms to measure against hydrogen. And this method in 1961, they further modify. Reason, because they say hydrogen is a gas and too hard to make a solid to measure with a gas. So they select another unit that is called 1/12 of a carbon 12. So the mass of atom are compared by the mass of 1/12 of a carbon 12. And this, what's meant by 1/12 of a carbon 12? Let's look onto the carbon. If you have one piece of carbon atom, I just imagine if I slice off a cake into 12 slices, and I take one pieces. This will be a 1/12 of a pieces of a carbon 12. So now you can see this 1/12 of a carbon 12 will be very equivalent to a hydrogen atom. The advantage of it is they both are now they are solid, so there will be an easier measurement. And now let's take one example. I want to measure oxygen. What is the weight of oxygen should worth? The weight of oxygen should worth around 16 pieces of 1/12 of a carbon 12. So you can say that is quite tongue-tiring, but that's how they set up. You can say 1/12 of a carbon-12 is look very much like a slice of cake from a carbon, and put it in one pieces, and so what are very much equivalent to hydrogen by weight. Now let's look on to another word, mole. What is mole? Mole is not a thing, it's not a noun. Mole is a description. It is a number. And what is this number? This number equal to 6.022 times 10 to the power of 23. This is a gigantic, super gigantic number. And of this number is too big. You hardly find any use of measurement of using this number, except in measuring atom. And let's see how big is this number. I give you one example. Let's say Australia, the whole continent of Australia. Imagine if you have 1 mole of rice, that many dots of rice. How much will be 1 mole of grain of rice can take? 1 mole grain of rice can cover up the whole Australia continent at the depth of 1,000 meters. So you will cover all the mountain. So you can see how big is this number. And students may think, wait, why we have this gigantic number to measure atom? And now let's go further and I explain. When we measure anything small, for example, let's say rice, you rarely will say, well, I want to cook 500 grain of rice, or I want to cook 600 grain of rice. Rather, you will say, I want to cook 1 cup of rice, or I want to cook 2 cups of rice, or I want to cook 1.5 cups of rice. Why are you using cup instead of count how many grain? Reason, when you have measured anything small, it is very hard to measure something by counting single dot or single particle. And this principle same apply on counting atom. So when you're measuring atom, you're not going to measure, say, how many single particle of atom, but rather you will have a cup, or you will have some way, a bigger unit for a measurement. You see, in this container, this cup, there is 2 relationships, the number and the particle relationship. So you can say that is 8 diamond, 8 times diamond. And if you have a look onto this number and the particle relationship, they have one very funny relationship. Whenever if the cup at the same size, in case if the number go bigger, the particle will go smaller. You not believe? I'll show you. Now the particle goes smaller and the number go bigger. And what happens if the particle goes smaller again and the cup didn't change in size? The number go bigger. What happens if this particle go further smaller and go further smaller and go further smaller? And you will expect the number will go bigger and bigger and bigger. And what happens if this particle goes small to the size of a single atom? How big will this number be if the cup's size didn't change? You're going to use this gigantic big Avogadro number. And that's how come we use mole to measure atom, like you use cup to measure rice. So from now on, we're going to using the unit as mole to measure against all atom. And we don't ask your mom, say, can I have 500 grams of rice for dinner? Same principle. So you will see this big number, mole, times the small particle, the weight of a single atom. If you times these two together, it will give you a size you can measure. And this size is the molar mass. The molar mass. What's meant by molar mass? The mass of 1 mole of atom. Molar mass means 1 mole of atoms, it weight how much? And this molar mass relationship is shown onto the periodic table. If you see, as we said earlier, this hydrogen, you see, we take it as 1, and we're going to measure, say, carbon, 12, or we're going to measure against oxygen, 16. And this is all a ratio relationship to establish this table. Imagine if you saw this whole periodic table is a ratio table. They measure against 112, carbon 12, or you can say very much like measuring with hydrogen. Imagine of the whole table, you times every number by 10. Say hydrogen, you times it by 10. Lithium, you times it by 10. Sodium, you times it by 10. Potassium, you times it by 10. So every number, you times it by 10. Will this ratio change? The answer is no, it can't be changed because it still will come to the same ratio. Okay, now I have another question. If I times it by 1,000, hydrogen I times 1,000, lithium I times 1,000, sodium I times 1,000, potassium I times 1,000, will it change the ratio? The answer, obvious, it won't change. So the scientists very smart, they say, okay, I times everything to 1 mole of a particle. I times it to 1 mole of that particle. I times it by 1 mole of that particle. Will the particle change? Will the ratio number change? No, the ratio is still the same. And the magic is, once you times it to 1 mole, now they all become molar mass. So now we say sulfur. This is sulfur. 1 single atom is 32.07. And what happened? One single sulfur, 32.07. What happened to 1 mole of sulfur? 1 mole of sulfur will equal to 32.07 gram. Carbon. 1 single carbon is 12.01. What happened? 1 mole of carbon equal to 12.01 gram. So you simply put a gram onto this bottom number. You simply put a gram onto this bottom number. Now this become the molar mass. So 1 mole of sulfur will be 32 grams, which is 32 grams per mole. So now 1 mole of graphite, carbon, 12 grams, or you can say 12 grams per mole. 1 mole of potassium dichromate, 249 grams, 294 grams. So it should be 294 gram per mole. Student, please know this unit may be a bit new for some student. Say for example 5 gram per mole. What's this? You will see this 0 minus 1, this minus 1 sign. What does this mean? They simply means if there is 1 mole of particle, it will be 5 gram. And so they both, you can represent in either way. And this way is a more common representation. So I hope students start to using this method. We come to the molar mass. We know the rule now. 1 mole of an atom or particle, it will equal to the atomic mass of the periodic table. And now you convert it into the molar mass. So what is the molar mass of magnesium? 24.31 gram. What is the molar mass of sodium? 22.99 gram. So that's very easy to make conversion. Okay, for example, let's say what is the molar mass of iron? 55.85 gram per mole. What is the molar mass of magnesium again? 24.31 gram per mole. What is the molar mass of nitrogen gas? 14.000, not 14.01, diatomic 2. So it's 28 gram per mole. So far we learned the single element, and now we know in the element it represents on the periodic table. So any element, we simply just put a gram onto the front and you will convert it into gram. Then what happened to molecule, which is not one element but rather 2 or 3, which is a molecule? And how do we deal with it? Now I show you. Imagine this is a H2O. Now this is a molecule. What do we do? Very simple. Add it together. So you have 1 gram of hydrogen times 2 because 2H and plus 16 gram which is oxygen. So total is 18 gram per mole. So the molar, you can say the molar mass of water is 18 gram per mole. NaOH, this is another molecule. You simply add it all together. 23 gram plus 16 gram oxygen and 1 gram hydrogen, total up 40 gram per mole. How about 1 mole of C2H5OH, which is an alcohol? Same rule, add it all together. Carbon is 12, so you need 2 carbon times 2 plus hydrogen 1, so you times 5 plus O is 16 and plus the last hydrogen 1 and total 46 gram. So means 46 gram per mole, and this is the molar mass. So on summary, we learned these 3 big words. Atomic mass. What is atomic mass? The mass of a single atom, which show onto the periodic table. And what is mole? That giant big number. And what is the molar mass? Also is the number shown onto the periodic table, but you just add a gram to it, and that's all. And what is the relationship of these three what is the relationship of this atomic mass, mole, and molar mass? The relationship is atomic mass times mole, it gives you the molar mass, which on the periodic table at a gram, don't forget.